everybody, and welcome to another exciting data club. Today we'll be doing some introductory text analysis or introductory analysis of textual data, or however you really want to talk about it. In 2 weeks, there will be a follow-up to this. So if this is something that is important to you, we may not get super far today, and a lot of the really cool stuff won't happen today. The really cool stuff I hope will happen next week or in 2 weeks. But today we'll be going over the kinds of challenges and the sorts of things that you have to think about when you want to collect information. My name is Moisir. I'm the research data librarian here. As always, if you have any questions about research data, go ahead and email us at data@library.columbia.edu, and we'll help out. Am I on the third slide or the? All right. So today, as the screen says, we'll be looking at Yahoo Finance. The notebook, the Google Colab notebook that we'll be using, this is the URL, so I'll read that out. It's columbia-data.club/march-23-textual-analysis.
And I should say that I'm Roger. I'm assisting, so if you have questions that are not group questions, I can come and help.
Yes, Roger is here to so that I don't interrupt the flow. On the other hand, today's notebook, it feels like it's really short. I know 2 weeks ago it was really long. This one feels kind of short, so maybe we'll get done early, and that's fine. Or maybe we can get kind of weird with your questions. That's also fine. So raise your hand if you do not, or if you have this open on your screen. Okay, so that's everyone. Excellent. So now I need to have it open. Wait, how many browsers do I have here? Go away. Okay. So I need to copy it, and I need to bring it up on my screen. So once you have this available, you should click on this button that says Open in Colab. And it will open up like this. Mine is super huge so that it shows up on screen and on the video. Yours will look smaller, and that's great. So collecting, well, I'll get into the collecting, but I'm basing this on this thing I found, a full guide on scraping Yahoo Finance by Octoparse. Octoparse is some kind of parsing software. I don't know what it is. I've never used it. But they wrote here, if I click on it, they write here, does Yahoo Finance allow scraping? And they say, in short, yes. So, when I get arrested for scraping Yahoo Finance, I'm going to say Octoparse said it was okay. In getting this notebook ready, I think I got banned by Yahoo Finance. So we'll talk a little bit about that, and a little bit about like what sorts of problems may have that. Come on in. I'll show you the URL for this notebook once you're a little established. So basically, today we're going to be talking about building a corpus, and we're not actually even going to end up with a corpus at the end. We're going to come very close. The actual construction of the corpus will be the first thing that we do in 2 weeks. Oh, and I also wanted to mention, in the meantime, next Friday, so not tomorrow, but in 8 days at 3 in Butler 208B, which you'll get an email about if you're on the Data Club email list, I'm going to be doing a workshop on using APIs, using a REST API in Python, which is similar to this, but not quite. There are basically, if you're working on a bunch of text, you have two, the first forking path is, does that collection of text already exist or no? Usually if the collection of text already exists, it's because you are a computer scientist who is interested in improving some kind of algorithm, and you don't actually care what the text is, or what the text is not super important. Oftentimes, the collection of text does not yet exist because you are asking some kind of research question that has not yet been asked, and you need to go out and collect that text. In that case, if the text is online, there are basically three ways to do that. One is, if you're super lucky, you can access the website's database and just get a dump of all of the content. Here's the URL for the notebook, if you want to type it in and open up the notebook. Accessing the site's database and getting a dump of all of the content, that's extremely unlikely to happen. But it could, and it's probably the best option that you get, because a lot of the metadata will be conserved that way. Option two is accessing the site's API. Things like we were talking about before we started. Websites like Reddit and Twitter have APIs, application programming interfaces, that allow computers to talk to websites, and you can get a lot of information that way. Many, not all, but many of the things that we have in the libraries, like Scopus, for example, have APIs that can let you do massive programmatic searches for doing like literature reviews and everything. Something like Scopus won't give you the full text, but it will give you, it'll give you references. I use Twitter and Reddit as examples in this little bit of text, but both are rather funny examples because Reddit's built-in API I don't think allows you to get the content of posts. You have to use another library that talks to Reddit in a specific kind of way. And the Twitter API is just a mess right now. Like in March 2023, we have no idea what's going on with Twitter. And if you actually click on this link, it'll take you to the API docs, and there's just parts where they're like, we don't know exactly how you can sign up for this level of access to the API currently. So it's a little bit ridiculous. So the technique that we'll be using today is scraping. This is the worst option. Scraping is, you really don't want to scrape stuff if you can avoid it. Or you want to pass that scraping off to some kind of library that does a very good job of making it so you don't get banned. A lot of websites explicitly forbid it. If you go to Facebook, if you look at Facebook's robots.txt file, for example, it says here, collection of data on Facebook through automated means is prohibited. So technically you are, come on in. So technically you are, in violation if you are, if you do any scraping. So Yahoo Finance's file is unclear, like they don't say anything. They don't say you can, they don't say you can't. So when octoparse says, in short, yes, that scraping is permitted, fine. Okay, but that all out of the way. Oh, and do not scrape websites you access through the libraries. So like Scopus, ProQuest, any of these like databases that give you massive query results and all that, do not scrape that stuff. Please email me or me and my colleagues at data@library.columbia.edu to help with accessing that amount of data. Because when you get caught for scraping, you put Columbia's whole you put Columbia at risk, not just yourself. So please contact us. And actually, we have an email, I think, in place that's like, hey, it looks like you're scraping this website. Please contact Research Data Services to avoid having to scrape stuff. So anyway, but scraping is possible, and sometimes it's exactly what you need to do. So wget is the first tool that I like talking about when we're talking about scraping, because wget, have any of you used wget before? It's a command line tool that downloads an entire website. Everything that has a link on a website. So it goes to like the home page and it recursively follows every link on the website and downloads that HTML document and the pictures and all this. It's very extensible, but that's, back in the 90s, that's what we used to completely suck an entire website down. You could also write a proper spider using a Python library like Scrapey. But we'll be doing everything kind of vanilla because I want to show the logic of what's going on here. So we'll be using the requests library to make vanilla HTTP requests, and we'll be using Beautiful Soup to parse things. Have any of you used Beautiful Soup before?
Heard about that.
What's that? You've heard about it?
Heard about that.
Yeah?
I used it but was not successful in downloading some files. So I just I'm a beginner at using it.
Yeah, so Beautiful Soup will be, I think it's a much more powerful library than what I use it for, but what I use it for is to understand an HTML document and give me only the content I want in an HTML document. Okay, so like I said, we'll be working with Yahoo Finance. So if we go to Yahoo Finance and then we go to the news page, so finance.yahoo.com/news, we get this rather straightforward page. Visually, it's pretty clear. You have this like header at the top. Then you have this sidebar on the side that has, I don't know, this is like 10, 20 articles on the sidebar until you hit a footer. And then this never ends. This is just an infinite scroll. When it stops here, it's only because it's grabbing more articles. So step one is let's grab this website and see what we can do with it. One thing to do with that is when we look at the structure of this page, and I'm going to do, I'm using a Chrome-like browser, so for me, I just have to right-click and go to Inspect. For you, if you're using Safari or Firefox, it may be a little bit different. Does anyone not know how to get to the inspector? All set?
Yeah.
Okay. So when we go to the inspector, I'm going to click here sort of inside this. I'm going to click here on latest financial and business news here and go to the inspector. And we see that there is, there's this div called main, and inside that, and then there are a bunch of divs, and then there is, I think it's this FinStream div is the one with all the articles in it. Yes. So it's this div with the ID FinStream that has a UL, an unordered list, that has just a bunch of LI elements. I'm not going to be spending a lot of time on teaching the HTML stuff. If you, hopefully it's clear enough, but go ahead and ask questions if it's not. So it's an unordered list with a bunch of list items, and if we click a list item open, we get more divs and stuff, and eventually we end up with the article, and the headline is here as an H3. You basically kind of have to just trust me. How major US stock indexes fared Thursday. So if I go back, we see how major US stocks, this is that H3. So this structure is really important because you have to sort of understand the structure in order to figure out where the content that you want is on the website. And this is why scraping is a real pain, because every single site has different rules, and the rules can change whenever, and they are under no obligation to tell you that they've changed the rules. And conversely, this is, I think, a reason why Yahoo Finance is targeted by scrapers, is because Yahoo Finance aggregates articles from a bunch of websites. So it takes these, it takes like Bloomberg articles, it takes, whatever, I don't know. But Bloomberg is one example. It takes Bloomberg articles, repackages them as Yahoo Finance articles, which means that you can get, let's say Yahoo Finance aggregates from 100 websites. So instead of having to write 100 different scrapers, you just have to write one for Yahoo Finance, and you get 100 websites worth of stuff. So I think that that's a part of, because I was asking my friends today how many articles they think Yahoo Finance publishes in a day. Do any of you want to guess? 100? Anybody else? Hundreds? I quit at 1,700. Like I was going through the thing, and I like told my little robot to go and keep getting articles. And when I hit 1,700, I was like, I don't want to risk getting banned again, because I got banned yesterday preparing this. I don't want to get banned again today, so I'm just going to quit and just say over 1,000. So over 1,000 articles a day get published. So there's this way through this FinStream, this div with FinStream has this unordered list, and then inside is all of the articles. So now we can do some code. So we import Beautiful Soup, and we import the requests library, and I wrote this little function here that you pass it a URL, and it gives you the HTML document, the whole thing, or it complains that something bad happened. So we run this, and it warns us, we say cool, and then, oh, I'm importing Beautiful Soup twice here. I don't need to do that, but that's okay. Then, so web page equals get web page. That's the function I just created. Here's the URL, finance.yahoo.com. Then I use Beautiful Soup, which is this object I created, and I ask it to parse this variable web page using the HTML parser, and then I get this parsed document. And then, oh, I did this in a slightly funny way, but that's okay. Then I create I have this for loop here that goes and finds every LI that has the class JS stream content, which is like this one here. You have LI class JS stream content. So find every single one, and then iterate over them, and print that H3, which is the headline. That I have this get text method that's part of Beautiful Soup that prints all of the text inside a tag. So that H3 only has the headline, so it's just one line of text, maybe two. And then it also prints a little number so we know how many articles we get. Because, like I said, this is infinite. This goes on forever. So if you've already run this, you probably know what happens. Let me zoom out a little bit for now. We get 26 articles. I have no idea why it's 26. But every time I do this, it gets 26. So Yahoo Finance is set up in such a way that it only preloads the first 26 articles. And I don't know what's special about that number. If you have ideas, I'd love to know them. Just for some reason, like when I was testing this earlier, it's always 26. It preloads 26 articles. So, you know, this isn't too shabby. We get 26 headlines right away, and this is where things get interesting. So if you are a business person who wants to be scraping Yahoo Finance, this is a step in the right direction, because you can write something that every 2 minutes or something calls up Yahoo Finance and says, give me the top 26 articles. They're the first, because the articles load chronologically. So just give me those 26, and you just keep building, and you build up a corpus that way. If you are not if you are not a business person but are interested in the past, this obviously won't work. You need to get at the information somewhat differently. And here we get lucky, because Yahoo Finance has a sitemap. And not every website, I think, has this, and this may be another reason why people like scraping Yahoo Finance. So if you go to, like March, so we'll be working with March 10th. My initial so March 10th is when Silicon Valley Bank failed. So my fantasy was to download every Yahoo Finance article from March 10th, and that we would work with that. And I think that that's what I'm going to do for 2 weeks from now, is work with all of the March 10th articles. But that's when I started trying to download them and realized it was going to be over 1,000. And I'm like, I can't run the risk of getting banned by Yahoo Finance 5 hours before this workshop. So I didn't do it. But if you go to March 10th, you see that it loads 50 articles, or it links to 50 articles. So it just gives us the headline, and then at the bottom there's a little next button. And if we click on the next button, it gives us the next 50, and then has a little start button here, and then the next button again. So this, it may not be obvious, but is something that is extremely iterable, and this is like gold, because there's no infinite scroll or anything like that. Instead, it's paginating things, so you kind of know how to work through it. And additionally, you can't really see this here. But the URL has a time code in it. This 1678408 that I have here, this is a time code. Epoch converter. So that's when I click next the first time and it takes me to page 2, it adds that timestamp to the URL. It says start blah, blah, blah. And that's showing me everything since Friday, March, the first 50 articles that were posted since 39 minutes after midnight on March 10th. And then the next one will give me another timestamp and another timestamp and another timestamp. So this is a way of it looks like you might be able to query the finance thing with a specific timestamp. I'm not 100% about that, because I don't know if it's generating these timestamps because it's counting 50 by 50. Well, we can try that. Why not? Let's add 10 seconds to this. Yeah, okay, so it works that way. So the sitemap interprets the timestamp that you send and gives you the first 50 articles since that timestamp. So this is all in UTC, most likely. GMT it says here, but that's probably UTC. So tools for people to know. You can call up Yahoo Finance and say, give me articles since the specific time in human history, since, I don't know, 2002 or whatever. So this is pretty cool, and we lucked out. And this is why I think, I wouldn't necessarily have, anyway. So what I want to emphasize here is that this becomes a creative endeavor, because you have to be creative about how you're going to be grabbing the stuff you're going to grab. So this is all I've talked about so far. And the way the sitemap looks, I don't have to show this, but there's another unordered list, another UL that has all 50 articles inside a div called sitemap content. And so we can do stuff to get the 500 articles. So here, I made this a little bit more complex than it has to be, just so you could see possible ways of iterating over this, which is that I created the date time, or the date March 10th as a date time object, because you can iterate instead of using strings to be 03_10, then just change that 10, et cetera, et cetera. Here you can just add a day to a date time object and get the dates that way. And then it gets the web page. Wait, did I skip something? No, okay. This is just the first 50. Right. So this is the first 50 articles that we get here. So here they all are. And again, they come in, I just had to print the headline. So it's effectively the same code as we had for the front page, except I changed a little bit about how the parsing gets done to account for the fact that it's a different looking website and the structure is a little bit different. The unordered list lives in a slightly different place. So you have to make these changes when you're dealing with this sort of stuff. So you can see here concretely, I have the parse document. I say find the div that has the class sitemap content. And inside the sitemap content, there are these LIs, the list items. And that's what I want. Those 50 LIs, those are the contents of the articles. Or those are the links to the articles.
Quick question.
Yes.
So we need to find the divs where the content is available.
Say that again?
We need to find the div where the sitemap is available.
Yes. Well,
Just
so
the way FinStream was there in the previous example.
precisely.
But how to get to that?
So we, okay.
I mean, how to identify the FinStream and sitemap
Sure.
so that we will be able to do this. So
If you, so there's,
yeah,
so if you get to this page, okay, so that's a good question, because some of this stuff to me is a little bit instinctive, just because I do it so much.
Okay.
So the way I like doing this. So here, let's go all the way to just regular March 10th. Okay. So the way I do this typically is I want to find where the thing I want,
Okay.
and I just hover my mouse over it,
Okay.
and then that's when I open up the drop menu and do inspect.
Okay.
And so this drops me right into here. And we can see here that this is A, so it's a link, and we can see that headline here, FT crossword number 17354.
Yes.
So that's exactly what I had here, right? So then I see that this link, this anchor tag, is nested inside an LI. So I know this list is what I want, right? Which is nested inside a UL, which is nested inside a div that has the class sitemap content.
Which is this sitemap content? I see a div. Yes. Okay. There's a module sitemap. So we should look at a module, a div which has a module. It could be a FinStream or sitemap or something else, which will have a list of these articles per day.
Yeah. So this is the problem is that structure is arbitrary.
Yeah, arbitrary to each website.
Yeah, and likely to change. So I remember I tried. I had a Twitter bot that made fake Donald Trump tweets, and it relied on this kind of structure to find where Twitter printed the text of a tweet.
Okay.
And it used these sorts of things like find this class, find this, blah, 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 blah. And then one day it broke and I didn't really care about fixing it anymore because Twitter just changed how they organize this sort of stuff, and then that was that. So that's why the question is really important because you can't just say, oh, do this. It's important to know how one can walk through the DOM,
Okay.
how one can traverse the DOM to find the document object model in order to find the thing that they want. So in this case, like tomorrow Yahoo could change sitemap content to something else and it won't be here anymore. Because if I just did show me all of the LI tags, then it shows me like the navigation bar and all this other stuff too, because this isn't the only list on this page.
Yes.
Similarly, these classes here, this is conceivably one way to do this, but these classes strike me as presentational. Like they have to do with like padding, and like PY is probably the padding on the y-axis. 3 pixels sounds good. LH is probably the line height, 1.2. List N, I have no clue what that means, but these are risky. I could say ask for every LI that has the class list N, but it's possible that could still include the noun. So here, this is really important, and I shouldn't have skipped over it so quickly. So that's why here I do this parse doc find div class equals sitemap content, so that I immediately limit.
Okay.
I dump everything else out, and this sitemap content is just that container, just that div container with sitemap content inside of it, and all that's inside of sitemap content. And this is good, because we see there are only 2 things inside. Well, there are 4 things inside sitemap content. A header, I don't care about. I don't know what this is. I don't care about it. It's probably the list of dates, the list of the 50 articles, and then this is the next button. That's it. So out of this whole complicated web page, I just get the content in here, which is not nothing. It's 50 articles, but it's just these 4 little things. That's it, wrapped in this one div. So and then I print this stuff. This is again basically the same exact thing, but with these different parameters to account for the fact that we have a different document structure here. Now, so I say here at the bottom of the list of articles, there's that next one, right? That we
You just need the URL to get to the collab notebook.
the URL for the Colab notebook.
Yes. Please.
Yeah, let me
I'll
pull
share
that
it.
up.
Oh, yeah, there's a shorter too.
Y'all aren't excited about this domain name, columbiadata.club? I'm very excited about it.
Is it a
There's-
separate website?
What's that?
Is it a separate
I
website?
think so.
There's nothing there right now,
Okay.
but it does do URL redirecting.
Okay.
So
Are we going to put something in the website?
there will be someday, and but not yet. Currently, it's just this. But this is I just started using these links like in the last 2 weeks, so it's still very, very new. All set?
Yeah, thank you.
All right, no problem. Sorry about that. Okay, so like I said, there's this next button, and then here we can see that there's that some epoch time. This is what I've been talking about already. Let me zoom back in. That I was talking about earlier, which lets you. I didn't know if this would work, but programmatically it lets you put in a specific timestamp, and it seems to return the 50 articles since then. A lot of APIs do this sort of stuff too, like there's like a since ID, or I think this is also a cursor. Like this is the original sense of the word cursor, which is where something that moves is, so you know what you've already passed over, and you only want stuff since then, like after that. Anyway, so the code has to be expanded to include. We don't just want 50 articles. We want to press the next button, theoretically, and then get the next 50, and then press the next button and get the next 50, and so on and so on. This is how I got this is what I meant earlier. I hit page 35, which is 1750 articles, 1,750 articles, and I was just like, keyboard interrupt, stop doing this. Because you can get banned. So the best way to avoid getting banned is to not do this on websites that explicitly forbid it, for one. For two, put in a little sleep. Chill, be cool. Wait a second, wait 5 seconds. 5 seconds is probably enough before you call up the website again. Don't just call it up a bunch of times right away. So we end up with this this big function called add articles. So I'll go through this in a little bit of detail, but I think everything is plus minus clear. So add articles, but there is something confusing / complicated about this. So add articles has 3 parameters. It expects a URL, it expects a page, default is 1, and it expects an array, a list called articles. By default, it's blank. The first thing it does is it uses my getWebPage function that I defined earlier to grab the entire HTML document. Then it uses beautiful soup to find the sitemap content div. Okay? And then it pulls from the sitemap content div every li. So all 50 list items, it pulls them. And it adds all of them to this array, this list called articles, which is blank to begin, or which is blank by default. Then it has to find the next button. So, like we saw here, 1, 2, 3, 4. There are these 4 tags here. In document object model terms, they are siblings. So this is the parent. The sitemap content div is the parent, and these are siblings, and then they have, each one has children. So the nav buttons are the next sibling after the UL. So we have the UL, the unordered list, and then the next sibling is this div. So this is the next sibling. So then we say the next button. So we call that nav buttons because there's 2 nav buttons. There's a start button and a next button. Well, the first time through, there's just the next button. The second time through, when you click next, the second time through it says start and next. So it gets them. It adds a 1 to the number of pages. And then I said stop when we hit 10 pages. So if the page is less than 11 and nav buttons exists, because I haven't been able to reach the end, so I don't know what's actually at the end. I don't know if at some point there's just no more nav buttons. This is what I'll try for 2 weeks from now. The next button, it finds all of the anchor links and it takes the last one. It pops the last one off of the list. This is, if we click here, oh, this is just the next button. Let's, okay. So again, we have the UL. Its sibling, the next sibling is this div, and inside this div are 2 A tags, AA. So here in this code, when I do find all A, it finds both of those. And then when I do .pop, which is a regular Python list method, it pops off the last value and returns it. So as long as So there can be any number of buttons here. As long as the last one is the next button, then I'm cool. If the last one is called end, or at some point there may be one that's like called end or something like that, then that won't give me what I want. But for now, I can assume that'll be next. But I double check here just in case that the next button dot text, this is all beautiful soup stuff. There's a dot text property which gives the text inside that tag. So if the text property is next, then keep going. The new URL, get the href property of the a tag. So next button, don't forget, is an a tag. So it's this here, right? And it has, like all well-formed links do, an href property that has the link, that is the link to the next page. I'm going super slow here because to me this is really tricky. But if it's very clear to you, I apologize. But to me this is the most delicate section of this entire workshop. So it grabs this link. It prints, waiting 5 seconds before getting articles from page blah blah blah. It sleeps for 5 seconds, and then this is the extremely tricky part. It then calls itself.
Recursive.
It's recursive, yes. So it calls itself with the new URL, sending in the new value for page, which has been incremented by 1, and sending the articles list, which the first time through articles gets 50 articles, and then it sends it, so the second time through it gets another 50, so now it has 100. The third time through it gets another 50, so now it has 150, etc., etc. So I don't know, again, that's why this is the most complicated section of today's workshop, because it involves both a certain amount of subtlety regarding traversing the DOM to figure out what the link is to get the next 50 articles, and also because it involves recursive programming, which can be conceptually very difficult. So what it's doing is this is a perhaps overly functional way of, like functional as in functional programming, way of saying while page is less than 10, do this, and this. It does it built in inside of it, and then it returns articles so that I don't have to feed it a list that I create outside of the function scope. So this is all done in scope, and it just returns a list of articles out the other end. So I was pretty excited about that, but it is a little bit complicated, and it makes perfect sense if you have a little bit of difficulty wrapping your head. Yes.
What does the pop line do again? The next button, there's not buttons.
Great. Pop is pops off the last member of a list and returns it. So there are a lot of ways to get the last member of a list in Python. You can get the -1th member of the list. Pop is sort of like the really old school way of doing it, because it's or at least in my head, it's the very old school way of doing it, because it really sets up the list as a data structure, as a queue, it sets up the list as something like not a queue, as a stack that you're popping stuff off of and working through. Because I'm pretty sure this is true in Python. When you pop something, it changes the list, because not only does it return, so it returns to you the last member of the list, but it also changes the list, so it's now smaller by 1, 2. So it's like, you can think of it like a to-do list. You just pop until the list has a size of 0, a length of 0. So yeah, great question. Again, like you can do -1 I think -1 is slightly bad practice. Well, it depends. Like, it's important to keep these kinds of trade-offs in mind. Like, do you not care about the list when you're done with it? Then something like pop might make sense. -1, if you want to keep track of this list and you don't want it to be mutated in some way, or you don't want it to lose an element, then there's then that's another way of doing it. The other thing with -1 is I think it gives you trouble if the list doesn't have a fixed size, a fixed length, which is just something I ran into while reading about these things, but I don't know exactly how you would do that in Python anyway. Like maybe with like a street, I don't know. Okay. Anyway, so because this is set up recursively, I can just do articles equals add articles like this. So I ran this already. I can run it again. And you all should be fine. This won't bang anybody. Because it waits 5 seconds and then it just gets all of the pages. And you can see down here how recursive it's just going add articles, arrow, add articles, arrow, add articles, arrow, because it's just going. Okay, and so finished. So it took 48 seconds, which is not a multiple of 5, but whatever. And so now we have these 500 Yahoo Finance articles from March 10th. What to do with this list? Well, we can turn it into a data frame. So here I'm doing 2 main things. One is I create a data frame with two columns. A URL, so this is the pandas part. I promised pandas, this is the pandas part. A URL column that finds, so everything in articles is a beautiful soup, whatever they call it, object. So it still has those methods. So it still has the find a method to find the link. And then it gets the href, so it gets the link. And for every article in articles. And then headline is it uses the text property, which is just what is the straight text content of this bit of HTML for article and articles. And then I add a third column that's called hostname, where I parse the URL and pull out the hostname just to see where are these links pointing. And this was important to me because if you look at the first headline here, it's FT crossword. And I was like, oh boy, if this is all FT website, FT articles, then we're not going to be able to scrape anything because FT, like everything, is behind a paywall, just not allowed. So I don't know exactly what they're doing with the FT stuff, but we can see that of the 500 articles, luckily almost 400 are to Yahoo Finance. So we're still we can still exploit Yahoo Finance's very open view on things, as opposed to moving to ft.com, which will presumably, well, I just know that until I started working at Columbia, I basically could not read the FT. And now you all have access to the FT. In case you didn't know, you can sign up with your Columbia email. This is a service provided by the library, and you can use the FT app, and and the FT app prints everything kind of in pink too, just like the actual paper. So there you go.
How do we get all those articles?
What's that?
Like we just gather the articles from here.
The FT articles? Yeah, you can just you can download the FT app and just use it as if you had a paid subscription to it. If you go to Butler, I don't know if actually at the front desk here, they have little things with the QR code to set that up for the FT and the New York Times also. You also have complete access to the New York Times. Okay. No free ads, but those are valuable things. It's good to know that you have free access to these things that people often have to pay a lot of money for. Okay, so we can look at what the data frame looks like, but it doesn't look like anything particularly interesting right now. It's just those 3 columns. Where you have the host name, the headline, and the URL. So as you can see, like this is why I was a little bit worried, because of the first 50 articles, like a whole bunch of them were links to the FT. This one I didn't read, but I did look at the headline, which is like Kant would be at a loss to grasp postmodern. Well, I guess it's here. I'm a little bit curious about what, it's not, so these are in a slightly weird or slightly funny order. But yeah, I don't know exactly what postmodern Europe is about. Don't need to bother you all with that. I'll look at that in my notes. Anyway, so next step, we only want the stuff that's on finance.yahoo.com. And if we go to one of the finance.yahoo.com articles, let me see if I can find one quickly here. Here's one. If we go kind of on the headline and inspect the headline, then we can see that Yahoo Finance very conveniently puts the article inside an article tag. This is appropriate HTML. Appropriate semantic HTML. Always great when that happens. So what we're going to do is, well, we're not actually going to do it because I already did it and it takes 10 minutes or 5 minutes, is run this function. So this function is somewhat similar to what we had. It's just expanding on what we've done already. So here, it sleeps for a second, it prints the URL, it grabs the web page from the URL that's passed to it, and then it does a try and accept. I had to add this because this is part of why scraping is such a pain, is because when it crashes, you get really mad. Because, like, think about this. You're downloading 2,000 articles, and you're assuming that all 2,000 work, that all 2,000 times you're going to call up Yahoo Finance, it's going to work more or less the same way, which is not a safe assumption. Articles can get taken down, those links might not work, there's any number of reasons why this might happen. So, in general, exception handling is a very, very good thing to do that we often don't do when we're doing these kinds of workshops, because the point is just to get this sort of information out there. But with scraping, it is vital. Without exception handling, this crashes on the first 20 articles, it crashes. So I needed to add this. So the exception handling is a try and accept. So it tries something, and if that crashes, then it just returns npman, which is the standard pandas placeholder for we don't know. Okay, so it parses the web page, and then it looks for the article tag. Like I said, they very conveniently put everything in the article tag. And then I use this method prettify, because what I want for now is just the straight HTML. I actually don't want the beautiful soup object that has all these extra methods. I just want the straight HTML. And the reason for that will be very clear in a second. If there isn't a document for whatever reason, just punt, return nan, return nan. Okay. This, if you uncomment this, will actually go and download all 500 or 396 or whatever articles. You'll end up with 50 that are broken for whatever reason. I didn't bother looking, but you know, if you cared about all of them, you would go and you would look to see what about the code is wrong that is making these 50 break, because it could be just one thing that would let you get all 50 of those. 50 breaking out of 300 out of 400, that's 1/8, right? Yeah, 1/8. I don't know if 12.5% fail rate is good. That's up to you to decide. And then I saved it as a Parquet file. So we don't have to do that. How much time do I have? Oh, not a ton. Oh boy. Yeah, so 50 of 393 didn't work, and I saved them as a Parquet file. So this is where we don't have to do that. I did that already. And now we can actually do a little bit of light text processing, and then we'll be done. Okay, so we install these libraries, text-to-C, and then we install Spacey's NCore Web SM is, I think, the English text processing model that's for English, and it's small, which means that it doesn't take up a lot of space, so it's not their best model, but it's a good enough one. And web, I think, means that it was trained on documents on the web. I'm pretty sure that's what that means. So we install these things. Yes, go ahead.
Sorry, what's text-to-C again?
Great. Text-to-C is so currently we're just installing these things. Spacey, I'll start with Spacey. Spacey is a text processing library that does natural language processing. It is, I think, the state of the art in Python. A lot of natural language processing was being done with the NLTK, the Natural Language Toolkit.
That's Stanford.
What's that?
It was Stanford's.
Yeah, that's that Stanford put together. That library is. I don't get as excited about it as I do about Spacey. Spacey has a lot more of the sort of machine learning-y driven stuff that that characterize contemporary natural language processing. This is how I understand it, at least. I could be wrong. So text-to-C is a wrapper on top of Spacey. Next week, or in 2 weeks, I don't think we'll be using text-to-C, because the thing that I like about text-to-C is that it has certain pre-processing tools that Spacey does not have, that I'll show you in a minute. So even though text-to-C relies on Spacey, it provides a little bit of extra sugar, and that's what we'll be looking at. And then how much of text-to-C is in 2 weeks and how much is just regular Spacey, I don't know yet, because it hasn't happened. So we install text-to-C, and then we download the model. The model is just the natural language processing model. It's just the black box that you throw text at it, and it translates it and figures out what it is, what to do with it. Okay. So then I have us re-import everything here just so that you can run this notebook from here without having to do all the stuff above. And we read this Parquet file that I saved to GitHub, and we can see it's exactly the same. Oh, why doesn't it? Oh, it doesn't start with the FT thing because I dropped all the FT things. It's just the Yahoo Finance things. Right, so it starts with the 6 cheapest places to eat at U.S. Disney theme parks. And you can see that it's the same thing. It's the 3 columns, and then there's a 4th column called raw HTML text, which has just the HTML document. Then I just started doing this. Like, I picked a random article, and then I made it so that the random state is always the same, so it's always the same random article. So it picked out this article for me, What Biden's War on Wealth Means for America's Richest. And and if we scroll through this, we see, oh, there's the story continues thing. This might be a problem, but let's click on it. Okay, so article, text. That sounds great. So let's chill with that for a second. Because what this code does, is it samples this random article and calls it sample. It prints the URL, that's what I have here. And then it also creates a file called article.html that prints out just the HTML. The reason I did this is because then we have this file here. So I got to that, I clicked on the little folder here to open up the file space. And I click download, and it takes a second. Wait, how come? That's weird. And then I get, when I open article.html, I get just the contents of the article tag. So all of the other stuff, so we can compare this to this, right? Like all of this stuff is gone. You know, the styling, I don't know what this is. Even the styling is gone. Somehow here in article HTML it says the telegraph, but that's missing from here. I don't know, do you see telegraph? Oh, up here. There we go. Okay, my mistake. So all of the styling is gone. And luckily, this was a huge break. Story continues, it still has the text afterwards. This is, like the infinite scroll where it does the lazy loading, where it only loads how much you've seen so far. I thought the story continues would mean that it actually doesn't load the rest of the article, but it actually secretly does. And I'm not sure why that story continues button is there, but now I used to think it was for loading purposes, but now I think it's for marketing purposes, because they can track who clicks on story continues, and so they know who's reading the whole article. But if you're a computer, you still get all of the text, right? So I was pretty excited about that. And so we see then we see it also has this trending section, but it doesn't include the comments or this other. So the comments I wasn't sure about whether it would include it or not, but it doesn't. And it obviously doesn't include like recommended stories or anything or any of this other stuff. So I wrote here in the notebook, and we're coming close to time, that a lot of the prefab code is kind of done, because this is where it really becomes a question for the researcher, for you all. Like, what here is important, and what do you actually want to grab? Like, there's and this is where, like, looking at article.html and then actually inspecting article.html. Let's do this way. We can see that there's a bunch of stuff here, even just in this article the article container. There's a bunch of stuff here that we can turn into metadata. So, for example, there is this class, and this I'm doing for the first time. So this is, you're seeing me try to parse this DOM in real time for the first time. So there's this class, CAS Adder Provider Logo, or this class here, CAS Adder Provider. So we could ask Beautiful Soup to get the text value of the span with the class CAS Adder Provider and create a new column in pandas that's called like provider, so that then we know the source of every article that we get, and we can do things like we can filter them based on that column, as opposed to being like look for the words the telegraph and it has to be capital T and all, like that's one thing you do. So this is what we'll be doing more or less next week, or in 2 weeks. Similarly, where was the? Okay, so that's the logo. Then we have the H1 is the headline. That makes sense, but we already have the headline. But then we can look for other stuff. So okay, so here's the body. Cast body wrapper. And then we have this button, read full article. Well, we don't want that, so we can skip, if we just want the article's text, we can skip all this stuff. You know, this will be script stuff that we don't have to worry about anyway. We can skip this provider stuff, save it as metadata. So we already have the headline, so we're not interested in any of this stuff. So we're actually only interested in the stuff that starts with cast body content. But it makes sense to save the whole article tag because it will still have this provider, which is useful. So cast body content. So what do we have in here? Okay, inner wrapper. So there's an aside. Yet again, good HTML policy, like well-structured semantic HTML. So they have the aside. If I had to guess, in this aside is where the trending information is. A bunch of stuff. Well, let's do this way. So if I had to guess, the aside is the trending. So part of this I can guess because I know it's at the bottom here. So where is this trending? It's in wafer trending bar, which is inside of wafer rapid module. So okay, so we have these IDs here: module quote lookup, module related quotes, module recent quotes, module trending, which we're not interested in. But we can see that these are all inside of this cast non-sticky SDA, which is inside of this aside. So that means we can get rid of the aside because we're not actually interested in that, or I'm not interested in that trending stuff. What I'm interested in is as much of just the regular text as possible, which is inside cast body section. But in here, things get even more, like this is all super, super complicated because it has to do with like the automated ways that these web pages get created and the way like it handles the content management system and all this sort of stuff. But you have to like walk through this piece by piece by piece to figure out where the stuff you want is. So for example, cast content byline wrapper will have the author's name in it. So we have cast author byline collapse, we have the author's name. So we can ask Beautiful Soup to give us to find the span with the class cast author byline collapse, and it'll give us the name of the author. We can ask for the time tag with cast adder meta time, and it gives us a date time. Look at this. This is a parsable date time. So currently we don't actually know when these articles are published. We just know they are published on March 10th. And this says it's actually published at midnight on the nose, or no, at 6 o'clock on the nose. This must be Pacific time, because it's March 9th, 10 p.m. So this is probably Pacific time. So it actually got published at 6 a.m. UTC, which is probably 8 hours off of Pacific time. So we get more metadata. We can get the metadata of how long they expect, what the length of the article is. Like this is all stuff that we can pull out and add to our data frame and add to metadata about the text. And then eventually we get to cast body, where we get more stuff, but importantly we get these P's. So these are paragraph tags. And so what we can do is we can go to div class cast body, pull all of the P's, and just grab the text from those. And presumably that would be the way that we get just the text of the articles. I don't know what this is. It's a blank div. has nothing inside of it. This is the read more button. We don't want it. So to get just the text, we say, give me the div with cast body, and give me the text content of all of the P's inside of it, all of the P tags inside of it. So I had a little bit of text to see stuff that I did with this one article, which we can quickly run through. I don't know how illustrative it'll be. So this I just did. I did a naive text of just like grabbing all of the text inside of that article tag. And then we can see what the text looks like when we just do that, when we just say, just give me, run.
It's reconnecting. It is reconnecting.
Oh, it's deconnected? Oh, I have the Roger problem.
Earlier in the semester, we had a room full of people who all could connect, and I was the only one whose Jupyter lab did not connect.
Yes, yeah. Well, in last semester it was a repeated problem where okay. So we're at time more or less anyway. But what I did here was I can explain rather quickly what happens here. Is I just pull all of the text from the article thing, so it includes the trending, it includes all that stuff. Unfortunately, I deleted all of the results, so I can't show them to you. But it shows you what the native text looks like. I can tell you it's a bunch of white space, a bunch of blank lines and stuff. So then we use text-to-speech pre-processing. They have normalized white space, which trims a lot of the white space. Normalized quotation marks, which changes typographically correct curly quotes to just the regular, the thing that you get when you type the button next to the return key, and etc. Text-to-see also has pre-processing things that can replace emojis, emails, hashtags, URLs. This can be helpful for anonymizing data a little bit. Removing the emoji can be helpful for if you're going to be processing something through something that doesn't know what emoji are. It can also be helpful because you can just say emoji is a noun or something like that, whereas it doesn't know what the actual emoji is. So when you do replace emojis, it replaces the emoji with just the word emoji in all caps. But you can tell it you can make up rules and stuff to make things nicer. So that when we run the pre-processing, you get a slightly prettier version of the same text. And then this is what we'll be getting into in 2 weeks, where we use Spacey to create Spacey's main object is called the doc, the document. So we convert every text object with all of the HTML tags stripped off into a doc, which then means we can do cool things with it, like extract all of the entities, which are organizations, places, and names. So if when you play this at home, or if you're still connected, if you keep playing, when you get to here and you press play, you will get Joe Biden, you'll get U.S. House of Representatives, you'll get a whole bunch of things, and then down here are just some text statistics. How many words are in the document? How many of them are unique? There's over 1,000 words in the document. 500-ish of them are unique, if I remember correctly. The diversity TTR tells you how diverse the text is. I'm not 100% on what that means. And the Flesch-Kincaid grade level, you may have seen this before if you use like a grammar checker or something like that. It tells you what the approximate grade level is for someone to be able to read and understand the article. If I recall correctly, it's about 10th grade, which is high for media. I think you usually want to aim a little bit more at like the 8th grade level. But finance stuff is maybe more complicated. Maybe the Telegraph, Brits are smarter. And then the doc includes like parts of speech. So if you run this, it'll tell you that there are 150 nouns in the article. There are 150 verbs in the article. It's something like this. I don't remember exactly what the numbers are. But it breaks up that 1,200 or the 500 unique words into a certain number of specific parts of speech. And then that's it. Thank you. Any questions?
So
Yes, go ahead.
how far are we from here to ChatGPT?
Very, very far.
YouTube offers me these videos that are like recreate ChatGPT entirely in code. It's like a 15-minute YouTube video, and I'm just like, but the underlying, like, the real answer to the question is far, because we're never going to get to a generative state. We're never going to get to so the next step, what we're going to do in 2 weeks is we're going to create a corpus out of all of the documents, and we'll be able to start like looking at them and looking about similarities between the articles or between all these articles, differences, etc., and start trying to understand it in some way. Hopefully we'll get that far in an hour and a half. I'm not 100%. But then what happens is once you reach that, then you have to create the model. Because the ChatGPT relies on this black box. It's the model. That's what it's been trained on. When you hear things like, oh, it's been trained on, like non-representative text, or it's been trained on blah blah blah, and these are the issues with the way the model reproduces inequalities that exist in our society and so on. That's what they mean. So we're not going to get that far. We're not going to train a model. We download a model from Spacey, and we use that to parse the text that we have. Spacey lets you create your own models too, et cetera, et cetera. So, and then with a model, then it starts becoming possible to do the sorts of things where you're actually generating text. But we won't get that far. Maybe next year.
And I mean, what's really expensive about ChatGPT is the training of the model on all the terabytes and terabytes of data. Once you have the weights, that's where it can go into your phone. That it's not expensive to use the weights to predict things. It's just expensive to train them.
Well, I'm not 100% on that because I'm not sure that it downloads the ChatGPT model. I think it's still relying on calls to. I think it's still relying on calls to. Just in my head, basically, you can't create ChatGPT unless you have a gigantic warehouse full of computers and a bunch of people you pay $1 a day to, which is what they did with ChatGPT. They had a bunch of people in Kenya that they paid very little money to annotate all of this text, and in order to let the machine be able to compare the text it's getting to something else and build this model. Because to build a model, the computer can't figure out a model on its own. It always needs something to sort of bootstrap it. And that has to do with any kind of training. You need to know what correct looks like first, and then you learn how to do things so that they look correct. But you have to basically pay someone or somehow create that corpus of stuff that is correct. And that's expensive. And then creating the model is computationally expensive. And I think even using the model, I don't know, maybe it does maybe there is like a 10 megabyte version of ChatGPT that gets downloaded to your phone or something. But I think a lot of that, when you talk to ChatGPT, I think a lot of that is being done on thousands and thousands of computers in some warehouse on the West Coast. But I'm not sure.
Cloud. Probably on cloud.
What's that? Yeah, the cloud. But, like they say, the cloud is just someone else's computer.
Right.
So that cloud it's 1,000 computers sitting in a warehouse in California or somewhere, or somewhere where electricity is cheap and the government doesn't really stick their nose into things and whatever. Sorry, but yeah, it's
we are starting. At least we are starting.
yeah. I mean, yeah. We won't get there because part of the reason I'm talking about this in the way that I am talking about it is because I think it's important to underscore that ChatGPT relies on an astonishing amount of infrastructure. That, like, just in terms of, again, the people that you have annotating the model, the actual computational resources needed to create the model, and then part of ChatGPT is you tell it things like, oh, you're wrong about this, which means that the model changes. So it's all this computation that's changing the model on the fly too. It's like this kind of power is only available to state-like actors and like 5 IT companies in the world. So
Maybe they changed the model. I thought it was like, because it didn't neural network, so I thought it changed. They go back to one cell of neural and they then proceed. So it's actually not.
well, it's reweighting things, and so like you're right. So in the sense that the maybe the entire model, however many gigabytes it is, doesn't change. It's just changing one little set of nodes, like one little set of weights. But it's still a huge. It's unfathomably large. But yeah. See you in 2 weeks or
Alright,
next week if you
great.
want to see how to
Thank
use the
you.
APIs. And yeah.
Great.
This time we will start.